Alright, so now we're going to talk about the second part of this notes, which are the actual solving of the polynomial equation. So if on the front of this notes you didn't have too much trouble doing that, then this is going to be relatively easy. All we're going to do, if you remember, is we're going to set each factor equal to 0 and solve. Now this is an interesting example. This is one that we normally don't do very much, but if you want to take a look at it and understand it, that'd be great. But if you don't, that's okay too. Normally we're not going to see a problem of that difficulty level. So let's go ahead and go straight into number one. So number one, what we're going to do first, remember, in order for us to factor, we have to set this equal to 0, meaning I'm going to have to subtract 49 from both sides. And when I do, I get x to the fourth minus 49. Now, if you look at this equal to 0, we're going to have to factor x squared minus 49. Excuse me, x to the fourth minus 49. So to do that, we're actually going to do a difference of squares. Again, we have two terms. They're both perfect square terms. So it's going to be x squared plus 7, x squared minus 7. Okay? Now, as you do this, see if you can factor this one more time. Now, both of these are not difference of squares. Mainly this is not a difference, and this one, 7 is not a perfect square. Okay, so that's all you can do in terms of factoring for this one. So once you get to your final factors and set each factor equal to 0, alright, and then now on this one, if I subtract 7, I would get x squared is equal to negative 7. And when I take a square root of this, I would get an imaginary answer. Okay, so since we're not going to have a real answer for this one, we're not really going to worry about this, all right, because that's going to be a negative. Technically, if you wanted to get an answer, you would get plus or minus I square root of 7. But again, that's an imaginary answer, which we're not really going to require from you. All right, on the second one, however, if you add a 7 to both sides, you can go ahead and take the square root of each side, and then the answer for this one is going to be x is equal to plus or minus the square root of 7. Okay. All you have to remember is if this is not a perfect square, then just leave it with the square root around it. All right. If you can simplify that, then go ahead, but otherwise just leave it like that. All right. Let's get on to number 2. On number 2, same idea. Before we do anything, we must set this equal to 0. So we're going to add an 8 to both sides, and that's going to give us this. Now, as you look at it, you count them. You have 3 terms, 1, 2, 3. So we're going to factor quadratically. All right, so we have basically half of that power right there. Factors of 8 add up to negative 6. They both have to be negative. This is going to be a 4 and a 2. Now in this one, you really do have a choice. On this one right here, you have a choice. You can keep on factoring, and notice that this is a difference of squares, right? So you can actually factor this into x plus 2, x minus 2 if you wanted to. All right, then set each factor equal to 0. Now, let me go ahead and do that on this one. So on this one, I can factor this one more time. All right, and on this one, I'm going to leave it like it is. I can't really factor that anymore. And now I'm going to set each factor equal to 0 and solve. Now, this one right here, if I set it equal to 0 and solve, I get this, and I would have that. You just have to be real careful. A lot of you are just going to want to write 2 again. All right, don't do that. On this one, I would recommend to actually write it out. Set it equal to 0. I'm going to write it over here because I'm out of room now. So you would have x squared is equal to 2. And when you take the square root of this, you get x is equal to plus or minus the square root of 2. Don't forget that the fact that this is a degree 4 function implies that you could possibly have 4 real roots or 4 real zeros. All right, so you have 1, 2, 3, 4. All right, so that counts as 2 more. Okay. Let's go ahead and move on to number 3. On number 3, let's see. Actually, once you do number 3 on your own, is essentially like this: subtract the 54 from both sides, and then factor it. And when you factor it, you should get plus or minus 3. And you should get x is equal to plus or minus the square root of 6. All right, so try it on your own. See if you can get that. I could be wrong. So if I am, let me know. All right, let's go to number 4 now. On number 4, remember, anytime we're factoring and when we're solving, we have to factor. And when we're factoring this, always look for your greatest common factor. In this case, the common factor is going to be 3. And between those two t's, the smallest one is t squared, so I'm going to factor that out also. Alright, and what I'm left over with would be, let's see, t to the 4th minus 16. Alright, so that's what I would have left. Alright, and then after that, we're going to go ahead and keep factoring if you can. In this case, this part right here is going to be t squared plus 4, t squared minus 4, because this right here is a difference of squares. And then if you can factor one more time, then do it. Alright, so right here I'm going to factor, I can't really factor that, it's not a difference of squares, so I'm just going to rewrite this. But this right here, this would be t plus 2, t minus 2. Right, this is another difference of squares. So this is one that doesn't look like it would be that long, but by the time you get here, you realize you have, let's see, 2, 4, 5, 6. Alright, so 6 roots essentially, even though 2 of these are going to be imaginary here. So set each factor equal to 0. Remember, you have to set even this one equal to 0, which essentially is going to give you 0, and this one's a double root. Right, this one right here, if you set it equal to 0, right, you subtract the 2, you subtract the 4, you would actually get an imaginary solution, plus or minus 2i. However, we're not going to have to worry about this imaginary, so if you don't get that, that's okay. But there it is in case you want to know. And then on this one, you would have t is equal to negative 2 and t is equal to positive 2. Okay? So that's that for that one. Let's go ahead and move on to number 5. All right, on number 5, we're gonna factor quadratically. So we have m cubed minus 8, and we have m cubed plus 8. Now, there's one thing I gotta say, that this one right here is a difference of cubes, and that one's a sum of cubes. Okay. Now I could expand that if I wanted to. However, when you expand that, you realize that the second part, the second part of the sum or difference of cubes, like this one right here, whatever you get out of here, if you set that equal to 0 and solve, it turns out that this whole thing is imaginary, and so is this one. Okay? And you may not understand that, but what I am trying to say is if you get to this, it's much easier for you to just go ahead and set this equal to 0. And then solve, because these are going to give you the real solutions. Alright, so we have m cubed is equal to 8, and on this side we have m cubed is equal to negative 8. Now, in order to get rid of that, I'm going to take the cube root. Alright, looks like a square root, but just with a little subscript 3 over here. I'm going to take the cube root of each side. Alright, now the cube root of 8 is just 2. It's not plus or minus 2. This is not a square root. So if you have a cube root, you just get one solution back. And on this one right here, you're going to get negative 2. Right? So in this one, you do have a cube root of negative 8, which is negative 2. Remember, if you were to multiply negative 2 times itself 3 times, you get back to negative 8. Alright, so those are your 2 answers for that one. Let's see what else we have here. I would love for you to do this one. If you can do this one on your own, you should have 4 answers. One of them is, or 2 of them are plus or minus 2, and the other one should be plus or minus 1. Alright, so let's go ahead and move on to problem number 8. Alright, on problem number 8, try to take out a common factor, and there is none. There are no common factors for these. Alright, so all you're left with is with either doing bottoms up or extreme factoring. Now, this is 576, okay, and this is 73. So when you multiply 4 and 144 together, you get this. Right now, I'm going to show you something on the calculator, which I almost literally hate to even show you this, just because I don't think a lot of you really do not know how to multiply and get factors on your own. So kind of hate to do this, but when it comes to something this big, right, something like 576 add up to 73, what you can do is type in 576 in your calculator, in your graphing calculator, and divide that by x. If you go to the table, right, so second graph, so you press second graph to go to the table, you're essentially, and by the way, both of these have to be negative. You're essentially looking for two numbers that add up to 73, but they have to be whole numbers. So I'm only looking at whole numbers. So for example, that one, I'm not even paying attention to it. So let's see, 6 and 96, that's 102, so that's not it. Let's keep going. 8 and 72, that's 80, getting closer. Right, we have 9 and 64. 9 plus 64 is 73. So this one right here is going to be 9 and 64. All right. So now that I've done that, I'm going to go ahead and rewrite this equation as 4x to the fourth minus 64x squared minus 9x squared plus 144 is equal to 0. All right. Now that I've done that, I'm going to go ahead and remember, we're going to go ahead and factor by grouping here. So we're going to factor out a 4x squared, which will leave me with x squared minus 16. And on this side, I'm going to factor out a negative 9. And that's going to leave me with x squared minus 16. All right. We're going to join those two together. So we have 4x squared. Remember, we're going to join this one and this one. Minus 9. And this one's x squared minus 16 is equal to 0. Excuse me. So after I've done that, you can keep factoring if you like, okay? And there's nothing wrong with that. And as a matter of fact, so this should be 2x plus 3, 2x minus 3, and this one would be x plus 4x minus 4. All right. However, I'm going to show you a way to do that if you want to do it. Just set each factor equal to 0, and then we're just going to add the constant to the other side, and we're going to take the square root. All right. When I add the 9 and then I divide by 4, I end up with x squared is equal to 9 over 4. On this one, I would just, much simpler, I would get 16. If you take the square root of both sides, this one right here, take the square root of 9, which is 3, take the square root of 4, which is 2. So this is plus or minus 3 over 2. And this one right here is plus or minus 4. But I hope that helped. Come with us with questions if you got them. We'll see you next time.